Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of 10th class maths. In the last session, we have discussed the initial concepts of similar triangles. We have learnt the basic proportionality theorem and its general theory, right? And we have discussed what are the conditions that when a line drawn parallel to one side, if it intersects two sides, then the ratio will be AD by DB is equal to AE by EC, right. Based on those theory, let us have few examples and problems in this session. Okay. Now see here, the question given here it is, here LM is parallel to AB, right, and he is asking us to find X if AL, that is this AL, AC, BM and BC values are given. Okay. Now let us see what is the solution. What is given here? LM is parallel to AB. Then what is the condition? If this LM is parallel to AB, then CM by MB is equal to CL by LA, right. This by this is equal to this by this, right. Now let us substitute everything. Does CM value given? No. Therefore, what is the value given? BC value is given, right. There is one more condition. What is that? Can I also write it as, see here, AL by LC, is it okay? That is equal to BM by MC, right. Is it clear? From this, do we have the value of AL? Yes, we have. Write it there, x minus 3 by, do we have LC? No, we do not have. At least do we have AC? Yes, we have, right. Therefore, this LC can be written as AC minus AL. What is AC? 2x minus, what is AL? X minus 3, isn't it? Next, BM, do we have the value of BM? Yes, we have, that is x minus 2. Do we have MC? No, we do not have. That is why we can also write it as BC minus BM. What is BC? 2x plus 3 minus, what is MC? Do we have? See here once again, BC minus BM. BM is x minus 2. Let us simplify and find the value, that is x minus 3 by 2x minus x is x, minus 2 minus x 3 is plus 3. Here also x minus 2 by 2x minus x is x, 3 minus 2 minus plus 2, 3 plus 2 is 5. Is it okay? Now let us cross multiply it. That will become x minus 3 into x plus 5 is equal to x minus 2 into x plus 3. Is it okay? Let us multiply. This will become x square, 5x minus 3x, that is 2x, minus 5 3s are 15. Here x square, 3 minus 2 is 1, here it is minus 6. Okay. Let us bring everything to one side. It will become x square plus 2x minus 15 minus x square minus x plus 6 is equal to 0. X square get cancelled, 2x minus x is x, minus 15 plus x is minus 9 equal to 0. Therefore, the value of x is 9. Is it clear? Once again, the given condition is LM is parallel to AB. He is asking us to find the value of x. He gave AL and AC and he gave BM and BC, right, and we know the condition, that is AL by LC is equal to BM by BMC, isn't it? Just substitute in that and simplify, you will get the value of x. Okay, right. Now let us see an exercise problem, that is the second problem in your textbook. There is a question given. In this diagram, in this figure, he is telling that LM is parallel to CB. Check here, where is LM? This is L. This LM is parallel to CB, that is in triangle ABC, LM is parallel to BC or CB or whatever, right. Then what is the condition? You can directly write, that is AM by MB is equal to AL by LC, right? Now let us take the second condition. LN is parallel to CD. LN is parallel to CD. This is in the bottom triangle. From triangle ACD and triangle ACD, what is the condition? LN is parallel to CD. That is, LN is parallel to CD. Then what is that we have to write? If LN is parallel to CD, then we can tell that AN by ND is equal to AL by LC. Is it right? From the first and second, I got the value of AL by LC, right? This is 1 and this is 2. From 1 and 2, I can equate AM by MB is equal to AN by ND. That is what he asked us to prove, right? Isn't it? Did you understand? That is a proof. What is that you have to remember here? The only condition when the line is parallel to another side, you have to write the condition, right? Let us check this third sum. Here in this figure they gave that DE, where is DE? This DE is parallel to AC, right? And one more thing is DF is parallel to AE. Then he is asking us to prove BF by FE is equal to BE by EC, right? Let us take the first condition, that is DE parallel to AC. DE parallel to AC. In which triangle it is? Bada triangle ABC. Solution: in triangle ABC, okay, DE is parallel to AC. DE is parallel to AC, right? Then what is the condition? BD by AD is equal to BE by EC, right? Is equal to, one is BD by AD, right, and one more is BE by EC. That is from this triangle. What is the second condition? DF is parallel to AE. DF is parallel to AE. In which triangle? That is ABE. Again, in triangle ABE, see here ABE, DF is parallel to AE. DF is parallel to AE, right? Now see here, what is the condition? BD by AD, BD by AD is equal to, here it is, what is here? BF by FE, BF by FE. If it is 1 and 2, if you observe here, BD by AD, BD by A similar, AD is similar, therefore the left out is BE by EC is equal to BF by FE. Therefore, from 1 and 2, I can write it as BE by EC is equal to BF by FE. That is what he asked us to find, right? Is it clear? Hope you understood this kind of problems, right? Let us move on to the next problem in the exercise. Okay, let's do them. Let us see the next question. The fifth question in your textbook, it is given that prove that the line drawn through the midpoint of one side, that is, let us draw the diagram. If this is a triangle, let us assume it to be ABC, right? He is telling that if a line drawn through a midpoint of one side, let us assume a midpoint D, okay, is parallel to another side. If this line passing through this and parallel to this BC, okay, then he is telling that it bisects the third side, right? Whatever the E it is there, he is telling that E is midpoint of this AC, okay. See here, let us prove what he is telling. Given what is given? Triangle ABC, right? Here D is midpoint, right? What do this mean? D is midpoint means AD is equal to DB. These both are equal, isn't it? This is midpoint he is telling, and one more condition he gave, that DE is parallel to BC, right? Then what is the proof I know? What is that thing I have to prove? I have to prove that E is midpoint, right? That is what he is asking, that prove that the line drawn through the midpoint, it bisects the third side. Bisecting means we have to show that is AE is equal to EC. That is what we have to show, right? Is it clear? Now let us prove. Proof is, see here, in triangle ABC, given that DE is parallel to BC. DE is parallel to BC. Therefore, by BPT, what is the condition? AD by DB is equal to AE by EC. Isn't it? Yes or no? And we know that AD is equal to DB, right? Let us write, instead of AD, let us write it as DB, right? Yes or no? Why? Since AD is equal to DB, which is given, you have to write the reason. This both get cancelled. Therefore, AE by EC is equal to 1. If I cross multiply there, it will become AE is equal to EC. Yes or no? AE is equal to EC. Then it is clearly that E is midpoint of AC, or I can write it as DE is bisecting, DE is bisecting AC. That is what he asked us to prove, right? Is it clear? Did you understand the concept, right? Now let us move on to the next problem. Here the question given here, it is this actually the 7th question. In this given figure, he gave that DE is parallel to OQ, DF is parallel to OR, right? And he is asking us to prove EF is parallel to QR. Okay, shall we do the problem? Now see here, he gave DE is parallel to OQ. These both belong to same triangle, right? Which triangle? POQ. In triangle POQ, what is given? DE is parallel to OQ, right? Then what is the condition? DE is parallel to OQ means PD by DO is equal to PE by EQ, PE by EQ, right? Let it be. Now let us check the second condition. DF is parallel to OR. DF, OR, these belong to this triangle, that is in triangle POR. What is the condition given? DF is parallel to OR. DF is parallel to OR. Isn't it? What is the condition? Again same, PD by DO is equal to PF by FR. That is PD by DO is equal to PF by FR. Isn't it? Is there any similarity? This is PD by DO, this is PE by EQ. PD by DO, PF by FR. Are those both same? Yes. From here 1 and 2, from 1 and 2 I can write PE by EQ is equal to PF by FR. Are these both same? Yes, they both are same. Now if you observe, PE by EQ is equal to PF by FR. In which triangle does it? In triangle PQR. Yes or no? There is a converse theorem. Yes or no? PE by EQ is equal to PF by FR. Therefore, we can clearly tell that BF is parallel to QR. How? By converse of BPT. Isn't it? That's the main condition, right? See here, PE by EQ is equal to PF by FR. Then I can directly tell it as EF is parallel to QR. isn't it? Did you understand the basic theory here? Is it clear? These are the two problems in this exercise. Let us move on to the next problem. Now see here, the next question given here, it is ABCD is a trapezium. Trapezium, how does it look? This is a trapezium, A, B, C, D. Okay, in which he is telling that AB is parallel to CD. Okay, and its diagonals, that is AC and BD, they are intersecting at a point O. Okay, then he is asking us to prove AO by BO equal to CO by DO, that is AO by BO equal to CO by DO. How to prove, right? If you observe, we can have the ratio between AO and CO when if there is a parallel line between this and this. Okay, can I draw a parallel line between these both lines? Say here, if I draw a parallel line parallel to, let us assume it to be some F. Okay, what is that in our solution? What is that we have to construction? What is that we have to do is draw OF parallel to AB, which is also parallel to CD, right? OF parallel to either CD or AB, we can do anything. Now if we observe, consider triangle ACD in triangle ACD, right? OF is parallel to CD, OF is parallel to CD, right? Then what is the condition here, right? AO by OC is equal to AF by FD, right? That is a condition, right? This is a triangle ma, this is parallel to this, right? Then this by this is equal to this by this, right? Now the next thing, let us consider this triangle, that is triangle ABD and triangle ABD. Okay, now see here, in triangle ABD the condition is OF is parallel to AB, OF is parallel to AB. Okay, what is the condition here? If OF is parallel to AB, then DF by AF, that is DF by AF is equal to, DF by AF is equal to DO by OB, DO by OB, right? If you observe these both things, here it is AF by FD, right? Here it is reciprocal of this. Let us reciprocal this, that is AF by FD. Here this also will become OB by OD, right? If you do not understand, I will write this D as like this. Is it okay? Now check from this 1 and 2, can I write it as AO by OC equal to OB by OD, right? From 1 and 2, I can write it as AO by OC is equal to OB by OD, right? Is that what he is asking us to prove? He is asking us to prove AO by BO is equal to CO by DO. AO, just cross multiply, you will get it as AO by, this OB will come to the denominator and this OC will go to numerator, OC by OD, right? Or else if I want to write as it is, here it is AO by BO is equal to CO by DO. This is what he asked us to prove. Is it clear? These are the questions of first exercise of similar triangles. Hope you understood most of the things. Is it clear? What all we discussed? We have started with the difference between similarity and congruency. Then we have started the basic proportionality theorem and the problems on them, right? Is it clear? Let us have few more concepts such as different kinds of similarities such as ASA, SSS kind of congruency, I mean similarity, and those problems related to them in the next session. Is it clear? Fine, done. Hope everything is clear for today. Let us have a few more discussions of similar triangles in our next session. Okay, thank you.